by just looking at some simplifications and also solving equations with variables that come about from these combinatorics formulas, from the NPR or the NCR. So to be honest, these don't really have much to do with coms and perms at all, but it's just around how do we manipulate the formula, okay? So we're gonna start with that, and then I think what I'd like to do today, if it's okay with you, because this last page is the end of this lesson, which is where I wanna be by the end of today, I would like to move into tomorrow's lesson and so that we can finish everything by tomorrow, finish the course by tomorrow. And then on Friday, basically you'll get like 2 review periods for this unit. But then I also wanted to find some time before the break to just walk you through all of the review material that you may want to look at some point for reviewing for the diploma exam. I hate to say that because I always make a list of stuff that I want to do before a break and then I don't do any of it, and I completely understand. But I do want to find some time in there to just show you where everything is and maybe highlight some things that may be more worth your time than others. Yes?
When are the quizzes and unit tests?
Quiz for this unit is on Tuesday next week. Unit test is on Thursday. So we will hopefully have a review period Friday and Monday. Quiz Tuesday, go over the quiz Wednesday, unit test Thursday. Okay? I'm really happy for all of our sakes, especially for yours, that the unit test is on a Thursday before the break instead of Friday, because then at least you don't have math last period. All right. Okay, so we're going to work with some of these factorial notations and just do some simplification. So first question, express in factorial notation. So we're going to do that first. And then simplify. Okay, so we've got n minus 1 choose 3 times 1 over n minus 2 choose 3. Okay, so the first thing that you might want to do is just write down or look at your formula sheet where you have the NCR formula. Right, so we know, okay, NCR is n factorial over r factorial times n minus r factorial. Okay, and then what we're going to start to do next is take this equation and take both of these n minus 1 choose 3 and n minus 2 choose 3 and put them into this notation instead. Okay, so for n minus 1 choose 3, and you may even want to do this off to the side. This will be, so the n is actually n minus 1. So it's this factorial, n minus 1 factorial, over this factorial, so 3 factorial, times this minus this, n minus 1 minus 3 factorial. Okay? And then also or actually you may even just want to do this. Just work with the denominator, right? So instead of putting it into a fraction right away, just think about what n minus 2 choose 3 is equal to. That's going to be n minus 2 factorial over 3 factorial times n minus 2 minus 3 factorial. Okay? So, and I'm actually going to simplify this a little bit more. This is n minus 1 factorial, the first one anyway, over 3 factorial, and then times n minus 4 factorial. And the second one that we're looking at is n minus 2 factorial over 3 factorial times n minus 5 factorial. Okay, so we're going to kind of take these guys and use them to multiply the first one essentially by the reciprocal of the second. Okay, so if we look at this, n minus 1 choose 3 times 1 over n minus 2 choose 3, that's going to be the first one, n minus 1 factorial, over 3 factorial times n minus 4 factorial times the reciprocal of the second one. So the reciprocal of the second one means I have to flip this. 3 factorial times n minus 5 factorial over n minus 2 factorial. Okay. Now, you don't necessarily need to do the first two pieces separately before you put it all into one. Okay, you could do that all in one step if you want, but sometimes when you're trying to, simplify and multiply by reciprocal and all of that, things can sort of get lost. Little details can get lost. Okay, so now we get to work with this. And we have to simplify it. And simplifying, really what we want to do is, with factorials, almost all of the time, factors will cancel. And so we need to make it as simple as possible. So one thing that I notice off the bat is that these cancel. Okay, 3 factorial numerator, denominator, that will make 1. And then the other thing that I want to keep in mind is that n minus 1 factorial, I can start writing that as n minus 1 times n minus 2 times n minus 3 until I eventually see something that I want to cancel in the denominator. And then from that point on, I can just write factorial. Okay, so what I mean is, like for the first one, okay, now I'm keeping my eye on this. Oh, the bottom is n minus 2 factorial. So if I just write that as n minus 2 factorial, then I'll have something to cancel with this. So I'm just going to put the n minus 2 factorial in there so that I know about that. And then n minus 4 factorial is n minus 4 times n minus 5 times n minus 6 times n minus 7, etc. I have an n minus 5 over there, so I'll just write that as n minus 5 factorial. And now there are several other factorials that can cancel. Right? So I have these guys and these guys. And I'm just left with n minus 1 over n minus 4. Yes?
How did n minus 1 factorial become n minus 1 times n minus 2 factorial?
Well, it's like saying 8 factorial is equal to 8 factorial, or sorry, 8 factorial is equal to 8 times 7 factorial.
But isn't that going down the way you would?
So it is going down because n minus 2 is smaller than n minus 1. Right? Yeah. I know it's kind of tricky. The other thing that you can do, like sometimes people have a trouble seeing sort of across the various expressions. You can also just kind of work with one at a time if you want. Like let's say we take this one. Right? This is just another option. So I'll do this maybe in a different color. If I take this guy and I work with it over here and I say, okay, n minus 1 factorial over 3 factorial times n minus 4 factorial. That's, the key is you want to simplify this as much as possible, right? And so that would be n minus 1 times n minus 2 times n minus 3. Now the next one will be n minus 4. So I'll write that as factorial because it's going to go down all the way to 1. And then 3 factorial is 3 times 2 times 1. So that's 6 times n minus 4 factorial. Right? So the first one actually simplifies to n minus 1 times n minus 2 times n minus 3 over 6. Okay, so you could do that if you want. And then take the second one, this guy, and simplify that one as well. Right? So if I take this one, that's n minus 2 factorial over 3 factorial. Oh, my pen is just catching up. Times n minus 5 factorial. I'm going to do the same thing. So I'm going to start expanding one of the factorials until I start to see the other one, because I know from that point on they'll cancel. So this is n minus 2 rather, n minus 3, n minus 4. The next one will be n minus 5. So at that point, I'll add the factorial in because I know it'll cancel with this one in the denominator. And this is now 3 factorial we just saw was 6 times n minus 5 factorial, right? So the second one, the first one is this. The second one is that, right? Now what I'm doing at the end of the day is taking the first one, multiplying by the reciprocal of the second. So if I take the first one, over 6, right? Now I got to multiply by the reciprocal of that one because it was 1 over n minus 2 choose 3. So that will be 6 over n minus 2 times n minus 3 times n minus 4. Okay? And now from this point, you can see from the individual factors, okay, well, the 6's cancel. There's a factor of n minus 2 that cancels and a factor of n minus 3 that cancels. And again, what we end up with is n minus 1 over n minus 4. Okay, so it's a matter of, there's multiple ways that you can simplify. And when you have these factorials that are a few apart from one another, you have options as to which you can cancel with which. So if you want to simplify each piece of it first and then do all your canceling at the end, that works. Then you're working with individual factors. Or if you can kind of see and practice a little bit and get to recognize when one of those factorials is going to pop up, then you can kind of just stop there and sort of cancel all in one go. Okay? All right, questions so far? Okay, so let's try this one. This is actually an equation. So here what we're doing, we have an equation, solve for n, if 720 times n choose 5 is equal to n plus 1 p5. Okay, so here we're not simplifying an expression, we're solving for an unknown because there's an equal sign there. Okay, so again, what I'm going to do is on each side, I'm going to simplify as much as I can using factorial notation. So the left side is 720 times n choose 5. Well, n choose 5 is n factorial over 5 factorial times n minus 5 factorial. Okay, and the right side is n plus 1 p5. So this will be n plus 1 factorial over 5 factorial times n plus 1 minus 5 factorial. Okay, and then what you can do is sort of chip away maybe at one side at a time, simplify each side first, and then work towards solving for n. Yes? Oh, shoot, you're absolutely right. You're right, it's np5. I'm sorry. So it's just n plus 1 factorial over n plus 1 minus 5 factorial. That was my bad. So npr is n factorial over n minus r factorial. Thank you. Thank you for catching that early. That would have been annoying if I had done more at that point. Okay? All right, so I think what I'll do is I'll work with one side at a time and get it as simple as possible. And then once they're both simplified in terms of canceling whatever factorials we can, then we can start to solve for n. Okay? So I'm going to leave this 720 alone for now. Now, n factorial goes down n times n minus 1 times n minus 2. So once I get down to n minus 5, it'll cancel with that. So I'll start by doing that. N times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5 factorial over, now 5 factorial, 5 times 4 times 3 times 2 times 1 is, 5 times 4 is 20, times 3 times 2 is 6. So 20 times 6 is 120. But you, again, you don't have to do that in your head. You can just go 5 factorial on your calculator and figure out what it is. And then times n minus 5 factorial. Okay, so I'll put my equal sign down there. On this side, this is actually n minus 4 factorial, right? Because n plus 1 minus 5. So I'll just do that so that I remember. And I'm going to do the same thing on this one. I'm going to start decreasing by 1 each time, the factors in the product, until I get down to an n minus 4 factorial, because then I can cancel it with the denominator. So this will be n plus 1 times n minus 1 times n minus 2 times n minus 3 times n minus 4. Now I know from this point down, it's going to cancel with the n minus 4 in the denominator, factorial. Okay? So now what I can do is cancel a bunch of stuff, right? So on the left side, well, 720 over 120 is 6. And this part cancels. So what I end up with is 6 times n minus 1 times n minus 2 times n minus 3 times n minus 4 equals, on the right side, all of this cancels. So I have n plus 1 times n minus 1 times n minus 2 times n minus 3. Okay. And what I notice is that at this point on the left side and the right side, I have a bunch of common factors. And so what I'm going to do is divide both sides by all the common factors. So there's a common factor of n on both sides, n minus 1, n minus 2, and n minus 3. That's sort of the overlap. Okay? So I will divide both sides of the equation by all of those common factors, n times n minus 1 times n minus 2 times n minus 3, n times n minus 1 times n minus 2 times n minus 3. And then what's left is not very much, actually, right? So on the left side, all of these cancel with all of these. So we just have 6 times n minus 4. And on the right side, these all cancel with all of these. So we just have n plus 1. And this is now a linear equation. So I can just expand. Right? I'm going to multiply in here by 6. So 6n minus 24 equals n plus 1. And maybe I'll subtract n from both sides. So I have all my n's on one side. And I have 5n minus 24 equals 1. Okay, add 24 to both sides. Some of you will do this part in one step instead of, I did it in, 24. I did it in 2 steps. And you get 5n equals 25, which means n is 5. Okay, questions about that? These are a little bit, you have to fiddly, I guess, to work with at first. But I personally, it's kind of like a trig identity. When you get it out, it feels really satisfying to simplify all of that stuff. Okay? All right.